Welcome to the session on engineering graphics. In today's session, we are going to see the projections of hexahedron. The problem statement given here is a hexahedron of 30 mm sides rests on HP such that one of its solid diagonals is perpendicular to VP. Draw the projections of the solid. So first we'll try to understand what is a hexahedron. So this is the 3D image of the hexahedron. Hexahedron is nothing but the cube, and we find this cube or hexahedron as a regular polyhedra. It means where all the surfaces of these solids are of having a square face, and the side here given it as 30 mm. So it means all the base edges are 30 mm, all the top edges are 30 mm, and also the lateral edges are 30 mm. So here if you see this O1, which is the axis of this solid, which is parallel to AA1, and the height of this O1 is same as that of AA1. So axis length will not be given separately for hexahedron, but it will be same as that of the base edge. So this is the hexahedron. So the top face is having the names A, B, C, D. The bottom face is A1, B1, C1, D1, and the axis is OO1. So this hexahedron has got 6 square surfaces having side 30 mm. So to draw the projections of this, we have to start with the XY line, and as the solid diagonal is passing from one of the corner, we have to start the square on one of the corner. So the resting corner is shown on the right side of the object. So first we have to understand what is solid diagonal and the face diagonal. So if you have got this A, B, C, D surface, and if you connect A to C, B to D, then AC and BD are called as face diagonals. So if you consider this A1, B1, C1, D1 surface, and if you connect A1 to C1, B1 to D1, you call it as a face diagonal. So solid diagonal is a diagonal where one corner of the base is connected to the opposite corner of the face. So suppose if I connect A1 point to C, so I get a solid diagonal. Suppose I connect C1 point to A, I get another solid diagonal. Suppose if I connect B1 point to the opposite direction, that is D, then I get another solid diagonal. So like this we have got 4 solid diagonals to the hexahedron. So here we are considering one of them. So 2 solid diagonals are passing through the corner. So that's why we'll be making the square to rest it on the corner, and we'll be drawing this square, and we'll be getting the center of this square by connecting 2 diagonals. So this is the first stage, top view, which we have drawn. Now if we project all the points like this, we have named it as AA1, BB1, CC1, DD1 and O1, and if we project it, we'll be taking axis length as 30 mm. So we'll be taking this as 30 mm, we'll project AA1, BB1, CC1 and DD1, and we'll be getting all the points marked here. So once we mark all the points here, then we have to make the solid diagonal here. So we are saying that we are taking a solid diagonal which is connecting A1 to C. So we can see that solid diagonal here. We have drawn a solid diagonal. A1 dash, C1 dash is one of the solid diagonals. So this is the solid diagonal which we have drawn. And then we have to draw one perpendicular to this solid diagonal from C1. So that is C1G is the perpendicular to this A1C diagonal. So now if you see this position of this diagonal, here it is inclined to HP and parallel to VP. So we have to make this solid diagonal perpendicular to VP. So at this position we cannot make this perpendicular to VP. So what we do, we make this parallel to VP as well as parallel to horizontal plane. So now at this position, when we have taken this figure over here and we have reconstructed, till we get this C1 dash G is vertical and this A1 dash C is horizontal. So once we get this position where A1 dash C1 dash is parallel to XY line or horizontal plane as well as vertical plane, we will be getting the projections of this. So projections we have drawn as a front view of the second stage like this by reconstructing the first stage front view, and next thing we will be projecting all the points like this and we will be naming them from A1 dash to A1 projection will be getting A1, then from B1 dash and B1 projector will be getting B1 here, and same we will be getting all the projections and we will be naming all the points here. So once we name all the points, we have to connect these points. So while connecting these points, you have to follow this procedure. So first this A1, D1, D, C, B and T1 are forming the outer points or the outer border. So outer borders are always visible. So we will be connecting them using thick line. Then second thing, when you have got the observer here, we have to see whether this ABCD phase or A1, B1, C1 phase is nearer to the observer. So in this case, the ABCD phase is nearer to the observer. So all the edges of ABCD will be visible. So ABCD are made visible and the other phase is away from the observer. So edges of other phase will be invisible. But the two edges of the other phase are forming the outer border of this solid, so that's why they are marked as visible. So remaining two edges will be invisible. So the third stage is that lateral edges passing through hidden points are invisible. So if you take the bottom face here, we have got this D1 C1 and C1 B1 is are the hidden edges and the C1 is the hidden point. So the edge passing from this C1 is C1C, so that would be marked as invisible, and remaining lateral edges are visible. So remaining lateral edges A1A, so that will be marked as visible, and you will be having O1 as axis point. So once we complete this second stage front view, second stage top view, we go for the third stage. So in the third stage, we make the diagonal A1C perpendicular to VP. So A1C is now perpendicular to VP. So A1C is perpendicular here. With respect to this A1C, we are getting the remaining points of the solids here. That is PB1, DD1, C1, A, O1, all the points we are getting it. And we are reconstructing this figure from this figure over here. So the reconstruction part is already explained in one of the videos. You can go through that procedure and you can reconstruct it. So here A1C is perpendicular to VP now. So A1C is one of the solid diagonal and it is perpendicular to VP, and we are supposed to draw the projections at this point. So this is the top view already we have drawn. Now we have to get the front view of this. So to get the front view, we have to take all the projections from A, B, C, D, O and A1, B1, C1, B1 and O. So all the projectors we have taken and we have named them. So after naming them, again we have to connect all the points here. Like say, once again I can explain you the procedure here. So say A1, D1, A dash, D dash, D1 dash, C1 dash, B1 dash and T1 are forming the outer edges. So you can go to the line, you can take a thick line 0.4 and you can connect this A dash to D dash to D1 dash, then C1 dash, then B1 dash, then B and then A dash. So we have marked all the outer points. Now the second stage, what it says that the edge contain the face or base nearer to the observer is visible. So now here if you take this A1, B1, C1, D1 is nearer to the observer than ABCD. So A1, B1, C1, D1 will be visible. So A1, B1, C1. So A1 is here. From here it will be visible, and then from here it will be visible. So if this A1, B1, C1, D1 are visible, then the other side, other face will be invisible. Other face is ABCD, but AD and AB are forming the outer borders, that's why they are marked as visible. So other two edges BC and CD are invisible. So again you go to line, you take the hidden edge and you connect this to this and this to this. So this you have done. Now the hidden point is C here, or the C dash. So the edge passing from C dash is C dash C1 dash. So again you go to line and you connect C dash to C1 dash as invisible. So that you have marked invisible. Now the remaining edge is A1 dash to A. So which is remaining edge? That we have to mark it as visible. So we have to mark it as visible. So A1 dash to A will be marked as visible. So the final solution of this is shown here like this, and we have used this procedure for the marking of the edges here in the final front view. So this is the final solution what will be getting. Thank you.